Today, we're going to pull back the curtain on something you do probably hundreds of times a day without ever thinking twice about it. We're talking about the incredible, invisible journey of a single click. Seriously, have you ever actually wondered what happens? I mean, you see a link, you click it, and boom, a new page appears. But that simple action, it kicks off this insane high-speed journey that can span the entire globe. So let's find out what's really going on behind the screen. So the whole thing kicks off the very instant you click. And that action, it's not just something happening on your computer. Nope, it's the creation of a message, a request that's about to be sent, potentially thousands of miles away. Basically, your browser instantly writes up a little note saying, "Hey, I'd like to see this webpage, please." And that note, that HTTP request, has to travel from your device, navigate this super complex web of connections, all the way to a specific server that could literally be on the other side of the world. And for any of this to work, all the computers involved have to speak the same language, right? On the web, that language is called HTTP, or Hypertext Transfer Protocol. Your click gets translated into what's called a GET request. It's really just your browser politely asking the server, "Hey, can I please get the stuff on this web page?" Okay, so the request is written. But you can't just toss it out into the digital void and hope for the best. It needs to be prepared, packaged up properly for its long and pretty complicated trip. You see, the internet is way too busy to send your request as one big file. Instead, it breaks it down into these small, manageable chunks called packets. Think of them like digital postcards. This is super efficient because it lets millions of different conversations from millions of people all travel over the same wires at the same time. This whole packaging process has a name: encapsulation. And the analogy of sending a letter is perfect. First, you've got your data. That's the letter itself. Then it gets wrapped in a TCP layer. This is like sending it certified mail. It makes sure all the pieces arrive in the right order and nothing gets lost. Finally, the whole thing gets wrapped in an IP layer, which is the actual envelope with the to and from addresses slapped on it. Now it's ready to go. It's wild to think about how this incredibly slick system we use every day got its start. One of the internet's pioneers, Leonard Kleinrock, tells this great story about the very first message ever sent on its predecessor, the ARPANET. All they wanted to do was type login. They typed L, then O, and when they typed the G, the whole system crashed. And from that one tiny failed attempt, the entire modern internet eventually grew. All right, so our little digital postcard is all wrapped up and ready to ship out. But where exactly is it going? It needs an address, right? And that's where the internet's giant address book comes into play. See, we humans like names. Things like www.google.com are easy for us to remember. But the machines that actually run the internet, the routers, they don't care about names. They think in numbers. They need a specific numerical IP address, kind of like a street address, to know where to send our packet. And that's the job of the DNS, the domain name system. You can think of it as the internet's phone book. Your computer basically asks the DNS, "Hey, what's the number for google.com?" The DNS server looks it up in its massive directory and sends back the right IP address. Just like that, our packet has its destination. Okay, address in hand, our packet is off. It's launched out onto the wire, starting its actual physical journey across this huge interconnected web of real hardware. Now, here's a key thing to get your head around. There's no single internet company. It doesn't exist. The internet is really a network of networks, a massive decentralized web of thousands of different networks, all owned by different companies and organizations that have just agreed to talk to each other and pass data along. And there's kind of a hierarchy to it all. Your little packet starts its journey by going to your local internet service provider. From there, it jumps to a bigger regional network. And from there, it hits one of the massive Tier 1 networks that form the super high-speed backbone of the entire global internet. And I really want to emphasize this. The internet is a physical thing. It's not some magic cloud in the sky. It's a planet-spanning mesh of actual tangible stuff. We're talking about the copper wires in your house, and even more amazing, hundreds of thousands of miles of fiber optic cables, bundles of glass thinner than a human hair stretched across the bottom of the ocean, shooting our data from continent to continent as literal pulses of light. And at every intersection of this massive highway system, there's a router. Think of it like a super fast traffic cop or a post office sorting center. Each time your packet hits a router, it quickly reads the IP address, checks its map, and in a fraction of a second decides the best path to forward it along to get it one step closer to its destination. But this journey across the big open internet, well, it's not always a safe one. Just like out in the real world, there are some pretty serious dangers and, frankly, bad guys out there looking to cause some trouble. The moment your data leaves your computer, it's out in the wild. And for all the incredible things the internet allows us to do, it is also a place where our information and our connections can be pretty vulnerable. So, what are we talking about here? Well, you've got things like denial of service attacks, where a bad guy just floods a server with so much junk traffic that it gets overwhelmed and crashes. Or there's packet sniffing, which is basically someone eavesdropping on your connection, trying to steal passwords or read your private info. And then there's source masquerading, where an attacker pretends to be someone you trust, like your bank, to trick you. But here's the amazing part. Despite all those potential dangers, the vast majority of the time, our little packet arrives safe and sound. All of this happens in milliseconds. It hits the server reads the request, grabs the web page, breaks it into packets, and sends the whole thing right back to you on the exact same kind of journey, just in reverse. And that's how the page appears on your screen. So where do we go from here? Vint Cerf, who's often called one of the fathers of the internet, talks about the Internet of Things. Think about it. We're connecting everything now. Our cars, our refrigerators, our coffee makers. As billions and billions of these new devices come online, all those challenges we just talked about, speed, reliability, and especially security, they're going to become even more important and way more difficult to get right. And that leaves us with one last kind of mind-blowing thought. The internet started by connecting computers. Then it connected billions of people. Right now, we're connecting all of our things, but the visionaries who built this thing, they're not stopping there. They're already working on the protocols for the next great frontier, an interplanetary network. So the next time you click a link and a page loads in a blink of an eye, just take a second to imagine what would it take to make that same journey happen, not just across an ocean, but all the way from Mars.